My name is Amir Hamdan, and today I'm going to talk to you guys about cryptography. And one of the main applications of cryptography is encoding and decoding text messages. So in this chart right here, it's displaying all the alphabets, including a space, by their numerical values. And the steps to encode and decode any message is first you type the message, then you encode the message using an encoding matrix, then you send the encoded message, then decode the message using the inverse of an encoding matrix, and then you display the decrypted message to the user. And for the example we're going to use today, it's encode and decode the following message, and the message is, "Where are you?" That's it.
Look. Hey guys, this is Ahmed Khalfi, so we're going to continue with some cryptography here. So for this example, we're going to encode and decode the following basic message, "Where are you?" using this 3x3 encoding matrix and these steps. So step 1, we're going to type out the message with letters. So after that, you turn the letters into their numerical values using that chart, using zeros for spaces. You get this set of 1x3 matrices. So these matrices are 1x3 because that's the only way they're going to be able to multiply with this 3x3 matrix. So after that, you start with step 2, which is encode the message. So you multiply each matrix piecewise with the 3x3 encoding matrix to get a subsequent encoded message matrix. So you do that for each of these matrices, and you get 5 subsequent encoded message matrices. So then you get to step 3, which is sending the message. So the message sends as these numbers, which are the same numbers as the numbers in these matrices. And then step 4 is decode the message. So to decode the message, you have to use a joint matrix to find the inverse of the encoding matrix A down there. So to do that, you use Gauss-Jordan elimination, basic row operations. So for example, the first step is to add row 2 and row 3 and put it in row 3. You get this matrix. And some of these steps have been combined to save room. So for this one, you add row 1 and 2 times row 3 to row 1, and add row 2 and 3 times row 3 to row 2. So basically, this is the gist of how to get the inverse matrix. So after you get the inverse matrix, you multiply it piecewise by the encoded message matrix, which you got from step 3, and then you get a decoded message matrix. And as you could tell, this matrix right here, which is, where'd you put it? It's right here. Okay, it's right here. This is the matrix. So this matrix is the same as this matrix right here, which proves we have gotten the same message at the end. So this phenomenon is important because in this day and age,